Okay, for question 1A, when it is a 3-mark describe the change in carbon emissions question. So you take a closer look at the diagram itself. It tells you if this is historic carbon dioxide emissions, global fossil fuel combustion, okay, from 1750 to 2020 in billion metric tons. So first thing you need to do is you need to check whether your answer, the unit of measure you gave, is it in billion metric tons. That is important. The legend is also given again on the y-axis, right? So on the x-axis is the years, and on the y-axis is emissions in billion metric tons. Now, what happens if you don't have the unit of measure, or your unit of measure is actually wrong? If you do indicate the wrong unit of measure, your answer will not be accepted, because unit of measure is very, very important. Now, when you look at the question itself, it covers the entire range from 1750 all the way until 2020. Now, such a question with such a graph can be one that takes up 3 marks, 5 marks, okay, up to 5 marks, depending on how you want to splice the graph itself and what kind of data you want to provide as evidence. Because you look at it, the growth is actually very stagnant until 1840, and then 1860 onwards it starts to increase until 1910 at a pretty increasing rate. Okay, so the first point I will cut off would be at 1840 or 1850, and the first descriptor I should have is that it has stayed stable, okay, with no change, largely from 1750 to 1840 or 1850, the first 90 years that it was tracked. Moving on from the next area from 1840 onwards to 1910, which is a period of 60 years, you need to note that there is an increasing trend of emissions, carbon dioxide emissions, okay, and then it reached a high of, this is about 4 billion metric tons in 1910. Moving from 1910 onwards to 1950, okay, this area here in 1950, you see a slightly different gradient. Okay, I would say a different gradient. So this section here from 1850 all the way to 1950, this 100 years, option is always there for you to deal with it together, because there is a change in gradient, but it isn't significant. So I would advise that you would cluster this together as one complete block, okay, 1850 to 1950, and then we will, instead of telling us that it is about 3 to 4 metric ton, it will go up to about 6 metric ton, okay, 6 billion metric tons by 1950. Okay, why 1950? Because if you look at the gradient onwards from 1950 to 2010, it spiked. Okay, it's really, really spiked. And then you have to describe that it's increasing at a much faster rate from 1950 all the way to the year 2000. Okay, year 2000, and then you do give me the corresponding data, which is about 25 billion metric tons by the year 2000. Okay, now why do I cut off a year 2000? Because you look at the difference between year 2000 and year 2010. These 10 years, it increased at even higher a rate. Okay, it's not only increasing, it's increasing at a very, very, very rapid rate. It's a very steep gradient, so that has to be handled on its own. The next 10 years, you have to highlight that there was a very, very sharp increase from 25 billion metric tons to about 34 billion metric tons. Okay, and then the final 10 years from 2010 to 2020, I would mention that it's still increasing, but the rate of increase has dramatically fallen, with the next 10 years only increasing by about 1 billion metric ton. So that is important. By talking about that, you will have shown that you have understood the whole overall frame. Now, always remember that when we talk about graphs like this, we are looking for overall trend. So somewhere in your statement, either at the beginning or at the end of it, you should have an overall trend that is mentioned. So the overall trend here is very clear. There's only one trend that you can actually show. Overall, from 1750 to 2020, the carbon emissions has increased, okay, at different rates, gradually and then at a very much faster rate eventually. So it has increased by a total of 35 billion metric tons. So these are the general areas that you should have covered. Okay, so if you're doing question B on what is greenhouse effect and how it impacts life on Earth, 3 marks. What are we looking for? Number one, whenever you are looking at a concept like greenhouse effect, enhanced greenhouse effect, please remember you need to tell me a couple of your greenhouse gases. Okay, so in your answer, do you have the greenhouse gases listed? Do you have at least 2? Right, that's important. If you don't, can you please add in 1 more? Okay, next, they want you to explain the effect. So you need to have a few key terminologies in your explanation. Number 1, what does the greenhouse gases do in this effect? Okay, it holds heat, it absorbs the heat, it stops your refracted long wave radiation from being shot back into space, so it allows it to rebound and reheat the earth again. So this process is important. This process causes heating. The idea is also important. And finally, when you're talking about this, the other component in the question is how it impacts life on Earth. So you do need to tell me how this will impact life on Earth. Okay, without greenhouse effect, what will happen to life on Earth? Will we be able to exist? Why not? Okay, why or why not? So that is important. So check your answers. Did you mention greenhouse gases? Do you mention what the gases actually do in this process called greenhouse effect? And lastly, do you mention how it is essential for life to exist on Earth? So that is question 1A and 1B.